Good afternoon, Build Stuff. I'm Dr. Laura Maguire, and I am a cognitive systems engineer. And there's two reasons why I'm in front of you today. One of them has to do with them. Today, without exception, all high-value work in society, in some way, is technology and software mediated. 112 routing systems, when you call the fire department in an emergency, uses software. Your child's doctor relies on an electronic health record to make sure your child doesn't have a deadly allergy to the medication they're about to administer. The operators at the electrical grid use software to reliably provide your elderly parents heat in the middle of winter. And the air traffic controller who's landing your sister's flight uses software to do that safely. So people who work in high-risk, high-consequence jobs all depend on software to notice, to decide, and to act. How nurses recognize that a patient is decompensating and getting them life-saving antibiotics uses software. Pilots safely landing planes after the engine has gone out use software. And train controllers who stop traffic at a station when something's on the track uses software. And in these jobs, minutes matter, seconds matter, and microseconds matter. So the difference between how software is designed, maintained, and operated can be the difference between life and death. And while you might think that the services or products that you're building or maintaining right now don't actually matter this much, what recent events from CrowdStrike, AWS, Cloudflare, GCP outages have all shown us that in highly interdependent and large-scale distributed systems, software that was never intended to be safety critical sometimes has, and it fails in surprising and unanticipated ways. And those of us who are looking at and studying societal scale integrated systems engineering see very clearly that the work that you are doing in software development really, really matters. So I'm here today to share some of the research and the frameworks and the engineering that help you to make their world better. The second reason that I'm here in front of you is you. It's to make work better for you, the developers. And for over 40 years, the fields of cognitive systems engineering, human factors, naturalistic decision-making, they've all been conducting research to develop generalized models of cognition in complex dynamic work to be able to engineer solutions that can better support work across many, many domains. And there's some really clear patterns across humans who do hard work. The cognitive functions of pilots, of nurses, of firefighters are remarkably similar to what we see in software developers. And we can use what was learned from nurses monitoring patients to design better observability tooling for monitoring code in production. We can take the findings of how pilots troubleshoot an unexpected engine failure to develop better models of how to debug code that's taken a system down. And we can take the findings from studying mission control operations at NASA to better structure the interactions across engineering, sales, product, compliance, to coordinate and bring together the perspectives at the right time to meet the multiple competing demands of each discipline. So doing this kind of engineering in software means you're shipping code faster with less bugs, less rework, and it means more uptime, and importantly, less stress, less frustration, and less burnout. And that's what I'm going to share with you here today, the very close and careful examination of what it means to do hard work. And this is based on the 8 years that I've spent studying software engineers and on the 40 years of cognitive systems engineering, looking at research across other domains. And my goal here today is to highlight to you the cognitive and coordinative work that makes software development hard, to give you new frameworks and language that you can use to describe some of the challenges you face, that can expand the possibilities for changes that can make work better. And in physical work, like landscaping, we often use ergonomics to make sure that the tool fits the job and they can do the job without injury. And so you can think about what we're going to do here today as cognitive ergonomics, to try and match the technologies to the job to try and prevent error, support productivity, and to reduce stress and burnout. And so as a cognitive systems engineer, I study cognition. And it's mostly human cognition, although increasingly it is machine cognition and the joint cognitive systems of how humans and machines work together. And we tend to view the thinking parts of software engineering as being, the technical work of writing and shipping code. But it is really much, much more than that. There's a whole lot of extra thinking that goes on, and that is the cognitive and coordinative work. And so whether you're in a meeting about the roadmap, whether you're deciding what bugs to fix, you're responding to an outage, or trying to get more headcount for a project, cognitive work is about asking and answering what's happening right now. Why is it happening? What will happen next? How quickly is that going to happen? What do I need to do right now to meet my goals and priorities? What might be able to be done later? What are the consequences of what's being talked about here for what it is that I'm trying to do? And what are the goals and priorities? And which ones, if everything goes sideways, can I sacrifice and still get the job done? So when you're observing changing conditions in the world around you, that's cognitive work. When you're recognizing the implications of those changes, when you're inferring what that might mean for your work, when you're anticipating how you might need to prepare for a change, prioritizing what you need to do next when time gets tight, if you're troubleshooting a performance degradation, diagnosing why the service is down, modifying how you want to deploy something, or correcting an assumption, or reacting to the project manager telling you that the customer wants to add new features. This is all the additional thinking, the additional cognitive work that it takes to do your job. And so another class of cognitive work is specifically about working with others. This is the coordinative work. And these are also cognitive demands. This is knowing and thinking about who has the skills and knowledge to help me right now. What do they need to know about the current situation or what it is we're trying to accomplish together to help resolve the problem that we're facing? What tasks should I take? Which ones should I give to them? Do I need to bring in other people in order to get this done? How long is it going to take? What are we not going to do? And what does that mean for my users? And how and when should I let them know? So the thing about this cognitive and coordinative work is that it's fundamental to getting things done. It's effortful, and it's really, really hard to see unless you're looking for it. And so the sources of cognitive and coordinative effort don't just come from you and your team. There's a whole system of work that surrounds you that also adds cognitive and coordinative demands. This is a sociotechnical system. There's code involved here, but there's also the people and the tools, including AI, that you work with. It's the leadership that you work under. It's the professional association you might belong to, the organizational structure that you operate within, any regulators you might need to satisfy, or regulations that you need to follow. These are things like the CEO pushing for the adoption of AI in your coding, and that changes your workflow, and it changes the cognitive work. It's reorganizations that change the way teams work together, and the goals that they pursue also changes the cognitive and coordinative work. If there's a talent shortage in the industry, and so you're running a little light, you impact the cognitive and coordinative work. And individually, any one of these things can represent significant increases to cognitive and coordinative work. But this is the real messy and noisy world. And they don't happen in isolation. They happen concurrently. They happen overlapping and contradictory ways. And to accurately understand cognition, we have to understand the interactions between all of these aspects of the system of work. So if you're learning how to vibe code in the middle of a reorg while your team is understaffed, the cognitive and coordinative demands are very high. It means creating conditions where there's more potential for error, there's less resources available for support, and more potential for stress and burnout. And so keeping track of the changes in the world around you is really quite effortful, and it's ongoing, but it's necessary to be accurate and complete. And so what you might notice here is that this is a very busy slide. It's the kind of slide that when you're a presenter, they tell you never to put up there. And there's a lot going on, but it's also representative of the complexity of modern work, especially in large-scale distributed systems. So there's a lot of pressures and influences that are being exerted from a lot of different angles. And these interactions, these multiple competing goals, the trade-offs that you need to make, the complexity, the effort, it's often hidden, and it's rarely talked about, despite the fact that this has substantial impact on your ability to quickly ship good code. And systems, they change when they get put under pressure. When a software system, influences or experiences a dynamic load, surges in user traffic on Black Friday, for example, we use scaling, load balancing, caching, rate limiting, to deal with the demands. And our systems adapt to the increased demands. And we say that they're kind of resilient because they can adjust as the conditions change. And so resilience and adaptation is really important on the people side of things as well, because everyday work is highly variable, things are always changing, and people are adapting by anticipating, prioritizing, modifying, and adjusting on a near continuous basis. And again, this is largely hidden effort. But normal work is all about changing goals and priorities and navigating goal conflicts and making those trade-offs. Customers change their minds about features, your boss moves a deadline up, your coworker needs an urgent code review. So any extra friction that arises from poorly designed work practices, interfaces, dysfunctional teams, or a lack of clarity around roles and authority, that requires a lot of additional effort, and it can increase the amount of stress. It impacts your ability to be resilient in the face of all these changes. So you are operating in a complex and dynamic environment. And when we think about resilience performance as connecting the cognitive and coordinative work, we have some capacities that we can think about. So I'm going to break this down into 5 core concepts that can help you with complexity and adapting to changing conditions. And those are recognizing very subtly changing events so that you can provide early assessment. You have more range of possibilities for action the earlier that you discover things. It's about revising your mental model in real time as conditions are changing. It's about replanning in real time. And it's about reconfiguring your available technical and human resources to meet those demands. And lastly, the reviewing part of it is kind of the learning element. It's how you've handled the work so that it can be improved upon. So I'm going to start off with recognizing here, because it's kind of the first step in the decision-making process. Because problems or events, they need attending to before we can take action on them. And noticing can actually be quite hard. And it's hard because we have a lot of things that are requiring our attention on a day-to-day basis. So I'm going to show you a little video here that is an example of this.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away. It's just a matter of observation. The real question is, how observant were you?
Action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
So how many of you caught the changes? Not a lot. It was pretty hard. And much the way that cameras kind of zoom in and out, we focus our attention on things that we deem important to the current situation and relevant to our goals and priorities. So from a perceptual data perspective, the world is really noisy, and we have to be selective in how we direct our attention in order to get things done. So recognizing is not a simple act. So let's break this down a little bit, because when we look at research into surgeons, firefighters, and intensive care nurses, how they sort of detect that there's a problem going on, how and why someone will recognize an anomaly, it depends on these two main factors. So what cues and signals are available in the world around them, and what are they expecting to be happening? And so the availability of that information impacts your ability to notice. And what the observer expects is going to happen, much the way when you were watching, you were trying to figure out what was going on. You weren't looking for all those other changes in the environment around them. That expectation drives you to search for specific cues and signals, which may or may not be related to the change that's happening around you. So another example of this is when you have good observability into multiple aspects of your build pipeline, you're going to get early indications if some aspects are slow or jobs are failing, which means that you could reasonably expect some problems if issues persist. And so this drives an exploration to see where some of the problems are. But let's say you've been working on a database migration for months now, and you're giving what you think is a regular status update in a meeting. And a VP who's skipped the last 4 meetings listens as you finish up the briefing, and they look up and you expect them to say, "Good job, carry on the work." But instead, they say that they're canceling the migration and everyone needs to start prioritizing shipping features in SPED. Because they missed the last 4 meetings, you missed the signs that they'd been feeling increasingly under pressure, and like the company is losing market share, and deciding that you need to ship new features and have that be the priority. So your expectancy was that the project was going to continue as expected, and the information to suggest otherwise was not available. And so you are understandably surprised when this expectancy is violated. And when we look at research into very dynamic sort of control settings, they follow a very specific pattern when people are faced with surprises. So if the pattern is kind of typical or it's known, they respond. They can do that in relatively straightforward ways. They can look at SOPs, they can look at rules. There's automation for very typical problems you might experience. But in non-routine events, this typically drives a search for further cues to understand if this impact is, I wasn't, paying attention, or I have the wrong understanding of what's going on right now. In other words, you have to go and do more cognitive work in order to find out information about the source of those problems. And this search for more information is an aid of answering the questions about what's going on, which way is the system going, or the situation going? Is it improving? Is it degrading? And how quickly is that happening? And these are really crucial questions for resilience, because how you answer them is going to generate additional cognitive and coordinative demands that have to do with how you're going to update your mental model about what's happening, what kind of goals you're going to have to sacrifice, who you're going to recruit to help handle it, and how you're going to use those skills and knowledge to solve the problem. So in other words, recognition drives this need for revising mental models, replanning your effort, and potentially recruiting and configuring new resources to help you change with those problems. So remember this system of work. Well, change happens at different times across the system of work, and time really matters when change is happening. But keeping track of all the changes across many different levels and many different aspects of work is very challenging cognitive work. So the VP might have been planning that pivot away from the migration for weeks or months, but because you hadn't seen them in a while, you hadn't had access to that, you missed cues that there might have been a change happening, and so you got surprised. So we know latency is a problem in software. Well, lag in information exchanges in the social structures around us is also problematic, because it prevents us from being able to anticipate, from adjusting, from correcting, from troubleshooting, from prioritizing, all of those additional cognitive functions. And so this brings us to the second cognitive or resilient capability, which is revising your mental model. So the less well-calibrated you are to recent code changes or to the organization's priorities, the greater the uncertainty and the more stress that you're going to feel. If you don't feel those things, then the greater surprise you will have when you encounter unexpected system behavior. And so being able to really quickly integrate new information into your mental model allows you to handle changing conditions more gracefully. So I got a little bit hand-wavy with part of that previous model that has to do with sort of model updating. So we're going to go a little bit deeper on that here. So we tend to define in cognitive systems engineering a mental model as this internal representation that we use to describe and understand complex systems around us. It's a model that's a simplification of how the system functions and how it can expect to function. And it serves to help us describe the way the systems operate, to explain how it's going to behave under different conditions, and predict what kind of changes that will have on performance. And it's the cognitive process that we use to adjust our expectancies and to validate our understandings. It's effectively a form of learning, of micro-learning. And so we call this model updating, and it's driven in real time, largely by that diagnostic search. You're directing your attention to new and different areas depending on those expectancies. And so the revision of kind of previous ideas about how the system is behaving happens as new information becomes available to us. But a really, really important concept in our understanding of mental models is that knowledge of the world around us, and specifically of the large-scale distributed systems that we operate, is always going to be inaccurate, incomplete, and buggy in some way. And this was one of the most important findings in my work with software engineers, because a lot of people feel like it's a flaw in themselves if they don't know something or if they have to ask. And really, as a system gets more and more complex, the ability of any one person to hold its function in their mind decreases. And so we need to coordinate. We need to align different mental models in order to have a more complete picture, especially as things are changing. So model revision is continuous. And in other words, you have to be continually learning and recalibrating and updating your view of the world. A simple example of this is when I come to Europe, I usually go to Ireland to visit family, and I drive quite successfully on the right-hand side of the road when I'm back home in North America, but I'm going to cause all sorts of problems for myself and for others if I do that in the UK. And so I need to update my mental model about what is typical and expected. So up until this point, we've been talking a lot about cognitive processes, about making sense of what's happening, the reasoning about the events that are underway. But now we're kind of starting to transition towards taking action. And hopefully it's obvious that we're decomposing this to kind of pick it apart a little bit, but all of these skills being deployed in real life is happening in concurrent and overlapping kind of process. So once we've identified that our mental model is poorly calibrated to the situation and we've got new information about the state of the system, we need to assess whether we're going to be able to achieve our goals. So in complex systems, there's always going to be multiple and often competing goals and priorities. So knowing how to replan is contingent on how well you understand those goals and which ones can get sacrificed as resources or time start to run out. So obviously system stability and reliability are higher order goals, but so is user experience. Updating mental models so that your engineers are able to respond to surprising events, developing new features that can attract or retain customers, reducing the costs of delivery, avoiding negative publicity. So you're constantly having to reshuffle around these sometimes competing goals. And this prioritization, the trade-offs that you have to make, the goal conflicts and constraints, this is a massive gray area of how to do this appropriately for many, many professions. And it plays out in discussions about paying down technical debt over building new features, keeping the system down to get more information for contributing factors to an incident, versus bringing it back up to meet an SLO, or hiring more headcount to better distribute the workload. So the cognitive work of real-time goal prioritization and communication requires, again, significant mental workload. So replanning also involves changing who we are working with and how we're going to work together. So reconfiguration is part of this replanning that has to do with how do we use the available resources, both the people and the machines, to meet our goals in real time. And I've called this one out specifically as a resilience skill because we often get trapped in org charts and job descriptions, sometimes for good reason, but it can limit our ability to bring in the right resources at the right time in a given situation. So in reality, to get things done, we have to work across boundaries. We have to work with people that we may not know and in ways that we've never done before. So this is a skill that needs to be supported and practiced. Dynamic reconfiguration, then, is reorganizing across this system of work according to demand and capacity, regardless of the existing structures or norms. The prime example of this is in incident response in software. The system goes down, say you're an online retailer, it's Black Friday, and the world is upside down, and order has just kind of been displaced. People drop what they're doing to lend a hand. And research in high reliability organizing, they identified that this reconfiguration across boundaries, my team, your team, and across levels is fundamental to getting things done in the face of surprise and disruption. And so they call this deference to expertise. And the classical example they use of this is on a aircraft carrier, where a ranking officer might defer to a very junior sailor if they're the ones who have the most information about a specific problem on a part of the ship. So what you see here is not necessarily hierarchical role structure, but rather a functional one. Who has access to the information, the ability or authority to make decisions, or access, restricted systems or conversations that are going to be helpful to accomplishing goals, becomes the functional aspect of that response that doesn't connect with the organizational structure. And I've only seen this kind of organically happen a few times. One was an example of an outage that happened, and the engineer that was kind of on call for this service was quite junior. And I watched very, very senior people within this organization jump into the Slack channel and say, how can I help? I'm here. What do you need me to do? And all the other affected teams similarly sort of jumped in and said, okay, how do we support you in getting through this? So the resilience skills here have to do with coordination, and it has to go into, again, understanding those resources that you need versus what's available, the skills, abilities, authorities, or access that they have that might be useful. So I've heard that Lithuanians really like basketball, so I thought this might be a good example for you, because the LA Lakers have this kind of dynamic reconfiguration thing done down pat. They tend to move about the court in a very smooth and coordinated fashion, anticipating where the ball is going to go next, adjusting, modifying correctly, depending on what the other team is doing. So what does smooth coordination look like? This is anticipating those events and the conditions. It's adjusting your performance relative to the demands. It's signaling your intentions about what you're about to do or what you think needs to be done. It's relaxing goals and constraints. It's demonstrating reciprocity by giving other people, relaxing your goals perhaps, or stepping in to help despite not having a benefit to yourself. And it's this investment in future coordination by building up the ability to share resources. And so when we talk about sort of aiding reconfiguration, there's kind of a couple of aspects that are really important. And this first one about working across boundaries is about relaxing goals and constraints. So the greater time or uncertainty, or time pressure or uncertainty that participants have, the more they have to relax their own goals in order to accomplish the activity. And so I saw a really great example of this in sort of relaxing goals and constraints and signaling intention while I was sitting in at a Dev Guild meeting in a mid-sized company that was experiencing a lot of real growth. And in the meeting, the SRE manager was discussing the results of her investigations into her team's interrupt-driven work, which had really expanded in the last couple of months. And as she was presenting her findings, another manager realized that the maintenance that they had been deferring on what he thought was a low criticality legacy service was likely to blame. And so He knew that he could help this manager by reprioritizing their workload and carrying out that maintenance. And after the meeting, he approached her and he worked with her to work out a plan that wasn't going to totally derail his team's goals, but it would save her team hours of frustration. And so making it known what goals are on the table, which ones are being sacrificed, and what coordinative capacity exists makes it easier for replanning and reconfiguring. And sometimes refusal to relax goals and constraints can lead to a collapse. So we'll talk a little bit about that.
The problem appears to be unsolvable. Maybe we could run some computer simulations.
There are too many variables. It would take forever.
You've got to be missing something. Let's start again. The movie is playing here at 7:20, here at 7:40, here at 8:10, and here at 8:45.
All right, these theaters have to be eliminated.
Why? They're state-of-the-art, digital projection, 20-channel surround sound.
Yes, but they have no icy machines. Despite my aggressive letter writing campaign, I might add.
What about the multiplex here? The seats are terrific.
They have Twizzlers instead of red vines. No amount of lumbar support can compensate for that.
Well, it's going to take at least an hour to eat, and I don't see a Sheldon-approved restaurant proximate to a Sheldon-approved theater.
We could eat after the movie.
Unacceptable. The delay would result in tomorrow morning's bowel movement occurring at work.
Hang on. There's a 7-Eleven here. We smuggle Slurpees, which are essentially ices, in under our coats after having a pleasant meal either here, or here.
Oh. I don't see how we missed that. Excuse me, in what universe are Slurpees ices?
That's how we missed it.
Sheldon, would you be prepared on a non-presidential basis to create an emergency ad hoc Slurpee icy equivalency?
Oh, Leonard, you know I can't do that.
Okay, I guess we only have one option.
Yep, I don't see any way around it.
Bye, Sheldon.
See ya.
They'll do it.
They're right, it was the only option.
So without relaxing goals and constraints, we can not meet our goals and objectives. So the last one that we're going to talk about here is reviewing. And this is learning, in effect. And learning, as we talked about earlier, with that mental model and the need to continuously update, is a very critical function for being able to adapt, being able to adjust, and to be able to maintain performance despite whatever conditions you actually encounter. And so work that I'm actually doing right now with the Department of Defense and with avalanche forecasters is looking at how do we introduce these micro-learning loops into everyday work to be able to be continuously updating our mental models. And I think software engineers are actually pretty good at this. When you do pair programming or rubber ducking with each other, you get an opportunity to expose your mental model or to hear about someone else's mental model and to make those adjustments and recalibrations in real time. But the level of complexity that you're facing means this has to be a sort of continuous process. So there's two resources here that I will kind of throw out there. One is the Etsy Debriefing Facilitation Guide, which really focuses on how do you ask the kinds of questions following an outage or following problematic issues at work that allow you to surface some of these assumptions and these beliefs and the knowledge that we have about how the system works. The other is something I co-authored with some of my counterparts at Jelly a few years ago, which is called the How We Got Here Investigation Guide, looking at software incidents as well, looking at that whole system of work and being able to ask the questions and bring in the types of frames of reference that allow us to look at what are the causes, what are the pressures and the constraints that we're working within to be able to address these at the systems level. So what should we do with all of this? The last 5 minutes here. I would not be a very good engineer if I brought up all these problems without offering some solutions. And so there are many kinds of interventions for supporting cognition and coordination and making work better that have a variety of degrees of complexity and that require different levels of expertise to execute properly. So I mentioned a few of those up front, work that we've done in intensive care units with interface and visual design so that you can support this kind of rapid sense making. There's decision support tools that can be used in very high demand situations to offload some of that cognitive and coordinative work. And there's coordination design, thinking about how do we structure the interactions with our colleagues, with our different teams within the organization to be able to have that really smooth coordination. And so what you can do here, like all kind of solutions, depends on the investments that you're willing to make. But whatever you do, you can't skip that close and careful examination of understanding what makes the work hard. Because if you do, you might end up solving the wrong problem, or you might inadvertently end up making things worse. So I've got a couple of kind of general things that you can try and enact with your teams, without a lot of effort. The first, looking at that noticing capability, is to generate a lot of opportunities to gain experience with system variability. This helps to expand your understanding of how the system works, how the system breaks, both on the social and the technical side of things. So this is really high quality training and simulation, game days, tabletop exercises. This is high quality learning reviews after something goes wrong to prioritize and emphasize what did decompensation look like and what did recovery look like. It's mentoring and it's knowledge sharing. Also making decompensation of all types more visible and giving it language for it to call it out. And so this is, as I mentioned, in your sort of observability tooling or in the tools that you have, being able to get better granularity there, but it's also in your workspace and watching when people are getting overloaded and being able to call out, we are not going to be able to handle this. How do we adjust kind of the prioritization of work here to be able to still accomplish the goals? It's normalizing kind of opportunities to reveal mental models. It's talking about goal conflicts very directly. It's shifting priorities and constraints. How are we going to do this? When are we going to do this? And it's this balancing heads down with heads up time. So there's a very common analogy within kind of cognitive systems engineering that sort of looks at how animals in the wild kind of necessarily move between foraging and eating heads down and sort of scanning the environment around them, looking for predators and prey. And so being highly proficient in your technical skills is not sufficient to kind of drive these results. You also have to have a network within the organization to understand how the work that you are doing is influencing other teams and parties, or vice versa. You have to stay current on the organizational goals and priorities. You got to do that heads up time as well. So there's a reluctance to bring up very legitimate concerns sometimes because it sounds a lot like complaining, but it's actually common grounding. It's getting on the same page about the skills, the knowledge, the beliefs, and the assumptions about the work that we're doing. And one of the things that we've seen that's quite effective is when leaders actually model this as well. They ask, what kind of conflicts are you facing? What are you not doing right now in order to accomplish what I asked of you? Another way of kind of doing this is looking at investments in adaptive capacity. It's in strengthening those informal networks, and it's encouraging cross-pollination across teams. So being able to invest in that building awareness across teams. And it's being experimental in your actions. It is engaging your team in identifying opportunities that can support adaptation, that teach you how to change in the face of surprises. This is about running pilots, small-scale pilots. It's learning from that, and these pilots might be things about how we interact, how we're expected to interact. Who do you call in if you're on call and you need help? It's stress testing these interventions before scaling. And one of the things that's quite important is drawing on implementation science, not just kind of change management. So here are some resources from the cognitive systems engineering, the resilience engineering world that can help you understand a little bit more about kind of how complex systems fail, how do we look at failure and success in other domains as well. And lastly, if we go back to where we started, to humans doing hard things, there's a lot of reasons, really good reasons to do this work, and there's a lot of ways to do this work, but regardless of why you do it and how you do it, I hope that you get started today. Thank you very much. If you want to connect, drop me an email or look me up on LinkedIn. Thank you so much for your time.